So this is for assignment 5, and obviously if you're listening right now and you're not here for the actual recording, um, wanted to let you know that of course this week, before spring break, that we're basically essentially tackling topography. That way, just in case you say are in D4 and you have access to the building, you could basically already get started and have free range to the laser cutter. We're not going to do something as complex as this. To be fair, this is kind of what I initially started with, and oh boy, so many students like, there's so many pieces involved. So, and to be fair, it took super long to cut, right? All these pieces, and of course, 10 students alone can take a couple of weeks. So I've simplified it a bit. However, the main idea is still there, and obviously you can use the exact same principles to, of course, achieve something of that level of detail. However, for this recording, I do want to express that, come to class, guys. It doesn't make sense teaching to an empty room. Plus, I give you all the time in the world to work on even various projects or even ask questions, about different projects as long as they're digital and things like that. So, a very lenient extracurricular class, right? That hopefully is benefiting you, and I already see the benefits in a lot of you guys in studio. So, without further ado, let's talk about some topography and at least what we need to do for exercise 5. If you're still working on assignment 3 and assignment 4, get them by the end of this week, right? Obviously, I'm not talking to the room. All these guys are pinned up just fine. But we will be talking those stairs on Thursday, right? Just at the beginning of class, which is about 8:15. So, let's talk topography. So I'm gonna need to open up, and I'm gonna basically, again, I kind of had a stairs assignment. I had my basic one, so I'm gonna start a new model, and of course, units first, and switch it to feet. I honestly don't know why in default it's millimeters. It is a UK program, so I'd imagine maybe that's why. But we'll switch it to feet, and of course, take a look at the assignment. So the next exercise is to develop the skills of digital design and fabrication in the context of architecture and to discover the techniques of utilizing the laser cutter for its speed and accuracy in model making. Our first task will be to select a 48 by 48 foot lot of space anywhere in San Antonio, and of course I'll go over the website as well. It is recommended that each selection is sloped and or vertically interesting lot, right? So don't just pick like a flat lot that's only going to have one topography line. You just won't get a lot out of the assignment. Will it be technically very easy? Yeah, I guess, but you might not get the whole gist out of it. To be fair, in this situation, you can really make up the lot too, or even use a pre-existing lot that maybe you've been challenged with in studio right now, or you just want to have something a little bit more familiar. However, in the past, we've had people choose San Pedro Park, their own lot. To be fair, if you can find the topography lines, I'm kind of open to anything. But if you've never used the contours and hydrology map of San Antonio, you're in for a real treat because, well, Bexar County, or sorry, Bexar County. Bexar County is for those of us who aren't from San Antonio. But Bexar County has actually had all the topography information, and just in case you're doing a project in San Antonio, it's definitely a useful tool to have. So we will be basically making those contours and tracing them, right? The question for selection is, where should your observation tower go? And of course, this is where the observation tower should be. So step 1, using the command contour, we can be useful. Using the command contour can be useful in already having a surface model. However, typically in studio, we are given our site and sometimes the topography and land surveyor information. After we have traced and created the topo model, we can now prepare the model to be sliced and printed via laser cutter. Pretty vague of a step 1, but let's dive into it. So first things first, I'm going to copy, and to be fair, that's kind of hard to copy in a PDF. So I'm just going to go to Google or your favorite search engine and type in hydrology and contours San Antonio. And usually it's the first one. Yep, COSA, contours and hydrology. It can be honestly a pretty dense map to load, so I might need to switch to, but as you can see, we can see all the different waterways and hydrology, but it also includes every single topography line known to man. And let me tell you, that's some pretty great information, especially if you're in studio, constantly being asked to define the slope or model these things. So we're definitely going to get into modeling these today. For me, I like to always pick a very interesting spot, and one of my favorite spots of San Pedro Parks that's probably the most interesting vertically is probably this northwest corner. So I just need to get a 48 by 48, and to be fair, I don't have the best graphic scale in the world. As you can see, that's about 40 feet, and if I zoom in and zoom out, it really doesn't have anything customizable. I can't really set that to 48. So we do need a screenshot first, and we'll probably need Google Earth, right? So I'm just gonna get something pretty fair. That way, I at least have a good amount. There's probably 48 by 48 feet in there. Let's also go to Google Earth Pro. In my case, you can use the browser as well. I particularly like Google Earth Pro with the desktop version, so I'm going to go ahead and use that one today, even though it does take a little bit longer to load. And in fact, I think I'll switch to my Wi-Fi, and maybe this process will go a little bit quicker. Put my phone in a more open area spot, and we'll get that to load. Sweet. So let's go to San Pedro Park and basically get that screenshot so we can line it up. Oh, probably a good idea to spell San Pedro correctly. Oh, wrong spot. There we go. Who knew there was more than one San Pedro Park? Wait for it. It's always great. When you're recording, the internet's slow. When you're not recording, the internet's brilliant. Yeah, it's a loading. But obviously what we need to do is essentially get that screenshot and overlay it. So very similar to like Illustrator or any other program, you can kind of overlay photography as well, and we can put it to scale just like we already know how to do. So in my case, I'm going to type in picture. I'm going to get that screenshot first while I wait for Google Earth to load. In my case, I put them in my downloads with screenshots, and of course that should be my screenshot. I'm gonna try and take a 48 by 48 square here. However, I don't want to necessarily just fake it till I make it. I may want to be absolutely accurate for studio, so this is where we start to definitely talk about scale and what we can do. However, as you can see, we can put in pictures, very similar to like AutoCAD or really Illustrator or any other Adobe program really. But we'll take that and we need to turn it into the actual, right? So we need a measurement of some kind. To be fair, usually the streets are about 35 feet across, anywhere from 35 to 50 feet, depending on how many lanes. So, I mean, we could fake it that way and we could draw a line that is, of course, matches 50 feet. But I do want to be a little bit more accurate, so I want to get that actual image. And it looks like I flew off into space a little bit. So let's find San Pedro Park. It's one of the biggest greenery areas in San Antonio. And more or less, let's get the same spot that we just generated. In my case, I'm going to turn a lot of this stuff off. That way I can basically just get a perfectly flat image. You'll notice if I turn on terrain, it starts to get kind of like a 3D model that's based on a LiDAR from a high altitude plane. It's kind of funny. Some people think that these are taken by satellites, but they're really not. And since the 1940s, they've been using high altitude balloons and planes that basically just kind of hover and take pictures, and then basically photo merge it all together, right? And you'll see that there's a difference between terrain models and, of course, the flat maps that, of course, are generated. In our case, I like to use that flat version because, well, it's going to be the most orthographic view and a little bit more accurate. You'll notice that if we select terrain, that it's actually a little bit off. It's a little bit stretched in order to basically kind of work with the spheroid. Anyway, so let's get that screenshot. Well, in my case, let's take a measurement first. In fact, I don't know about you, but I like this feature as well. We can go back to 1995 and see what SAC looked like. And this is exactly what I mean. They didn't have that satellite in 1995. They were, of course, taking high altitude photography. And specifically, if you go over cities like Paris or really old cities, they have a lot of old 1945 shots of the old city. So I don't know about you, but I constantly am referring to history in my architectural design, and I very often need to show the differences. Oh yeah, this is before this was a parking garage, right? Used to be tennis courts over there. Anyway, even the planetarium is just the planetarium instead of the whole Scobie Center. Anyway, always kind of nice to look into the past. But you can choose which shot you do want to take from, and of course which one's going to be most accurate. Man, that green looks kind of fake, but anyway. We'll keep it at February 2024. They are updated pretty frequently, especially with Google Project Loon, which is basically a giant balloon floating over us all the time. Anyway, not sure how that works with airspace, but obviously I'm trying to give some time to let this thing load a little bit. Anyway, we do need to take a measurement, and for the sake of our project, it'd probably be a good idea to just use 48 by 48 feet. So in my case, I'm going to draw 48. And as you can see, it's pretty small. So I'm going to get as close as possible. I may need to zoom in a little bit. Of course, use Shift to get that and dial that in. Getting pretty close there. I'm going to fake it till I make it. 48.06 feet is pretty close to 48 feet. So I'm going to go ahead and save that. And I'm going to make sure that it's in my screenshot when I take that screenshot. It's looking pretty sweet. And we'll get a gist of it and just make sure that it's in there. Awesome. So let's go ahead and, I don't know if you can actually drag this in. Yeah, and to be fair, make sure that you select picture. Don't select wallpaper or material or environment. It'll immediately change the entire environment. And to be fair, I don't know how to get it back. So usually I have to start a new file. So I'm going to type in picture and just kind of fake it till I make it, get it fairly close, and just about right. So one of the first things that we need to do is, of course, make a 48-foot line. So I'm going to type in line, enter, 48 feet, enter. And in my case, I got to click a base point first, 48 feet, enter. And we'll make a 48-foot line. Now, as you can guess, we got to tell that picture to match this 48-foot line. And as you can see, it's right there. However, first things first, we can't really see the line. You know, it's kind of hard to see. And to be fair, it's kind of hard to see these images. And as you can see, they kind of like go back and forth between which one it wants to show us. And it's because they're technically in the same spot. They're breaking Newton's second law of motion, right? Where two things cannot be in the same place at one time. Anyway, in the digital world, we can do whatever we want. So let's get those together first. I'm going to highlight both of them and change their material, right? So I'll go to the little paint bucket, or sorry, little paint tube, and I just want to add some transparency, in my case, maybe about 50%. That way I can, of course, see through these objects, and we can maybe see our line a little bit better. So I'm going to line up the base point of my line to the base point of that 48-foot line. Pretty close. I could also just move it and be a little bit more precise. Get right in there and lock it into place. So there is no question. Next, I'm going to scale it just like I've done in previous assignments. I'm going to choose my base point. I'm going to choose the end point of my measurement, fairly close. I'll probably try and keep it straight there. And again, I don't go to the fuzziness of the color. I go kind of to the direct point of that color. You guys kind of see that? I mean, once we zoom in, everything kind of turns into pixels, but you know, I try to be as accurate as possible, and it gets fairly close. Now we need to decide where 48 feet is, and there's the end of our line. Awesome. And now this image is to scale, right? But as you can see, we got way too much. And to be fair, I just messed it up. Set view, go back to plane. There should be a way to actually lock those in. I just don't have it set. Now the next part is we want to get our topography lines close enough, right? I mean, they don't have to be like absolutely perfect. And to be fair, nobody's ever going to go in and go, hey, are these topography lines correct in Studio? However, in the real world project, you might, right? Especially when it comes to building something. However, for this assignment, we can fake it till we make it and get it generally close. As you can see, we can see the topography lines kind of match with what's going on there. And let's keep going. Probably a little bit bigger, I can tell. And just kind of faking it until I make it. I know there's kind of a huge hill that basically goes on there. And for the most part, that's looking actually pretty good. I could probably line up the streets to it. Awesome. And you can see, pretty darn close. Maybe a little smaller, actually. It's gonna get in the edge of that street. Actually, a lot smaller. There we go. So we're a little outside of the original measurement, but that's okay. We can take something of that size. I'm gonna take a rectangle, 48 by 48. So 48 feet by 48 feet, enter. And just kind of find the square that I want to trace. In my case, we'll make it simple for the tutorial today. And I'll do something with a little complexity over there and, you know, kind of smooths out a little bit. So I'll take that piece, I'll trim it. Well, in my case, I might want to make a copy because I might need something later and I don't want to do that necessarily all over again. So let's make a copy. And I can even hide one of those if I need to. But I'm going to take the whole thing, trim, and basically get rid of the images. Sweet. So, lack of a better term, those are about my pieces. I don't really need all of those pieces, I just need this guy. And the reason we needed that satellite image was, well, we might need some sidewalk information, we might have a tree involved, and there might be some other information that we need. So I'm going to take both of those and get to drawing. So usually this part is pretty easy, and most of us have probably traced something before. So let's go ahead and do so. I'm going to go ahead and make a new layer and call it topography. Or just topo. Not tupu, topo. Yeah, there we go. And usually I like to color it green just to have some continuity. And let's draw a polyline. So in my case, I like to use my splines or my control point curves and just get to drawing. As you can see, it's pretty pixelated, so we're gonna kind of fake it till we make it. And note that the way that I draw this is not exactly to the line because eventually we're gonna have to trim it out, right? So very often I kind of want to have some extra pie crust. Has anybody ever made a pie or a cake before? Right? And you have to make a little bit extra. That way you can actually cut off the excess. Same kind of thing here. We want to have a little bit of excess so that we can cut it off and maybe possibly deal with some surfacing issues, as you can see later. I'm going to make a few mess ups on purpose and actually do this a couple of different ways. That way, you know, if you were rendering something, obviously you may not want the cardboard look. But if we're laser cutting something, you might definitely want the cardboard look. That way you can actually get all those layers a little bit easier. As you can see here, we're going to have a couple layers. 1, 2, 3, 4, 5, 6, 7, and technically 8 being the bottom piece. So there are a couple ways to do this. However, the first way is to definitely trace it first. So I'm going to go way out there and bring it in. And as you can see, kind of just faking it till I make it. I could also control these point curves, so it's not imperative that it's absolutely accurate when I draw or trace this, because I can further change them. But again, a lot of access, or excess, I should say correctly. I'm going to hit spacebar again, and basically do the same thing. As you can see, if I choose 40 lines, this is going to take a lot longer than tracing 2 lines. But for the sake of tutorial, I'm going to go as fast as I can. And if you're following along, it's a good spot to follow along. Now that I think about it, I should put like classical music in the backgrounds. But we are technically drawing on the 0 plane. These lines should all be basically at a level, right? And to be fair, we probably do something like this, especially if we're making a diagram of some kind. Very often when you're doing site plan analysis, is kind of our first step, is of course finding scale and tracing the right pieces. But notice how we're doing it 1-to-1 scale. That way, you know, I know Professor Boslav likes to go from 1 to 100 to 1 to 50 to 1 to 1/16, and anywhere in between, right? So very often I make it 1-to-1. That way I can always change the scaling of one of them. I don't necessarily have to make a different diagram or trace every single time. Work smarter, not harder, but also work harder. And we're just about finished, not too bad. As you can see, I'm pretty inaccurate about it, but I also, It's for the sake of tutorial. But again, plenty of excess, and we should be pretty good to go. I'm going to go ahead and make a copy, just because I don't want to accidentally mess up and do that again. And I should probably be a little bit more organized, but to be fair, this is kind of just a fail-safe. I don't really technically use it again, unless maybe for a diagram. So that's looking pretty good so far. Let's take a look in 3 dimensions and make sure that it's flat. If it wasn't flat and I accidentally clicked on something, have I shown you guys what you can do? How do you make things flat in Rhino? Anybody? Any guesses? Flatten. No, I'm just kidding. Make 2D, right? If it's 3D, make it 2D, right? So for instance, let's just kind of throw in an error there just in case. Like, so for instance, maybe one of my points got like really off, right? And you're like, oh man, that's not gonna work. I need flat lines in order to do that. So I would actually take my whole piece. I'd make sure that I was in the top viewport, type in make 2D. And I would probably turn off my hidden lines, just because it's gonna give you a weird line for that. So I'm gonna press apply. And as you can see, just in case you accidentally mess up, you can always get those lines back, right? And of course, they're perfectly flat again. Anyway, just kind of want to throw that out there just because I've noticed some of us, when we trace stuff, we accidentally hit another line or we accidentally hit another piece and we start over, kind of the first intuitive thing to do. And what I'm trying to say is you don't have to, right? Of course, you can use the flat plane. In my case, I'm just going to edit undo and continue on from there. Now, to be fair, we can assume if you actually go back to the hydrology and contours, it actually does tell you the numbers of each of these lines. However, it does skip some and you kind of have to follow the line, and your screenshot may have been out of focus in terms of some of these circles that were going on, right? Or sorry, these indicators of elevation going on. So in my case, I might need to reference back to the image. For this project, I'm just going to assume that our bottom is 0, right? So our edge, I'm going to go ahead and make a rectangle. And that will be my bottom piece. I'm going to go ahead and extrude it so that we can basically see it a little bit. And to be fair, how big is a topography line? Anybody know? 1 foot. Pretty simple. So I'm going to do 12 inches, enter. I'm going to go, of course, put it in shaded mode. That way you can kind of see what's going on there. I'm going to go ahead and hide my image. That way we can see that a little bit better. But the first method I want to use is the cardboard method. And I think that one's probably the easiest because it's, well, the easiest to understand. And as you can tell, we're going to need a base. And, well, if I wanted a really thick base, I could, right? I could basically build up those layers. And it's pretty intuitive. I'm essentially building the model 3-dimensionally. I'm going to refocus and calibrate myself. That way, when I spin around, I just look at this object. However, the next thing that needs to go up is this guy. So, to be fair, I like having that access. That way I can take all my lines, right? A little bit easier. Curve, curve. And I need to move up everything 1 foot. So I'm going to use that line, make sure that I'm in the right spots. It's looking pretty good for the view that I need. Go ahead and move 12 inches. I might want to hit ortho, especially if I want to keep it absolutely straight. And in this case, I definitely do. So I'm going to make that one 12. And then really, that one's at the right spot now. So let's get the next one. It's looking pretty good. Basically just move it up a foot again. 12 inches, enter, and enter. Next one. And as you can see, it does take a little while, especially the more lines you have. I'll type in move again, 12 inches. And as you can see, it's starting to almost create like a wireframe slope. Right, we can start to see those come up. And you can see, of course, which line needs to go up next. Sweet. Type in move, enter, 12 inches, enter. Almost done, 2 layers to go. What's great is you can actually take this wireframe model also and import it into Revit, and it'll make a surface for you automatically as well. And of course, we'll actually refer back to this exact project when we get into Revit in the last 4 weeks. But that's looking pretty sweet. And as you can see, it's kind of got this wireframe mode, right? So the next thing that we can do is, well, we can turn it into cardboard surfaces, right? However, we'll need some things, right, to say the very least. We'll need to either extrude these and sort of create a plane, or we can basically kind of solve the rest. So first things first, I have a cardboard method. We'll save that for later. But there is another method, basically a lofting surface method. So I want to show you both because, well, one is great for rendering and one is great for model making. So let's go over the easy one first, just because the lines are already kind of prepared to do so. I could take each line and essentially loft them. So we'll take all of those and let's just kind of see what happens. I'll show you, of course, what happens. It's not going to be perfect. So if I type in loft, holy cow. Kind of crazy, right? It may not be kind of the best way to do it, but in my case, we can go to rebuild with something a little bit more simple. And what this tells me is that some lines are flipped. However, keep in mind the way that I trace this. Some lines I started from the top and I traced down. Some lines I started from the bottom and traced up. And that actually causes the direction of the lines to change. So you see how it's kind of like flipping in on itself? Be careful when you run into these errors. That's because some of the lines are technically flipped, right? So what we can do, of course, to fix that is flip some of the lines where those things are happening. I literally type in flip, enter, nothing happens, but it has flipped the line, right? It's flipped the normal of the line. Impossible to see in the digital realm, but technically the code has changed. It's basically just reversed the code of that line. So in my case, let's try that again. Curve, 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 and curve. Let's try loft again. Okay, so a little bit better, but still kind of getting messed up in there. Let's flip the last one. Flip, enter. And again, we'll take those lines. In my case, let's delete these real quick because they keep getting in the way. Plus, I already have them, so. Makes it a little easier to select and loft. Getting a little bit better, but as you can see, it's just not going to work, right? It's really struggling. It finally got like the end piece of that and kind of all the way around, but it's just not the same. So what do? Well, we need some more lines. In fact, to basically tell the computer, hey, I want you to go all the way out to here. So in my case, really excess, right? And a lot of excess there. And we definitely want to get this part as well. So I'm going to go ahead and make a line from there and to about there. Not a big deal. Oh, actually make the line. Enter. And technically we want to put it at the same level of that pretty close surface, right? So in my case, I'm going to kind of just fake it till I make it. Welcome, Ellis. Going over some topography. But basically setting up my loft. Right, so I'll take each of those pieces, again, including those little outside ones, and let's go ahead and loft that as well. And as you can see, it's just not going to work unless maybe I actually put these together. Let's try that. So as you can see, it works in some cases, but definitely not all cases. That's pretty wild. Although I'm not gonna lie, pretty inspirational if I wanted to make something. However, let's go over a different method, just because that one doesn't seem to be working too well. Oh, wait. Let's try a closed curve. It's worth a shot. Worth a shot. Forgot I have some more tricks up my sleeve. Let's trim that off. Won't let me trim that off. Why? Oh, because it's not actually touching. Oh, it looks like it's touching. There we go. It can be applied to a closed curve, so let's try that. join. And let's try lofting those. Oh. Doesn't even want to try. Oh, am I in another command or something? What's going on here? Mistakes will be made. Come on. Oh my goodness. What is going on here? I apologize. Not sure why I can't select something. Okay, there we go. Loft. Enter. Oh, I have caps lock on. That's... Why won't you loft? Unable to loft. I guess one is closed and they must all be open. So that's definitely good to know. I wonder though. Kind of just want to see what that does. Not as great. All right. Let's try that again. You can change your surface like that. Hey, okay. So technically, you know, slightly accurate, at least more than the other. However, let's go over a way that is a little bit more efficient and of course works a little bit better. In my case, I'm gonna make a copy, and I kind of messed up that one, so I'm just gonna make another. Also, I should probably take ortho off. Let's go ahead with the cardboard method, because we could also make a smooth surface out of the cardboard piece too. So either way, we can kind of go back and forth on this one. However, I do have another video on this one where I do go over the loft surface, and I don't know, it's just based on the topography. Sometimes it works, sometimes it doesn't, which is why I include a couple methods, right? In my case, I think the cardboard method is probably going to be a little easier for us. So I'm going to go with something, actually, this might be easier, right? One that's already flat, because, well, I need to draw some extra lines. But it can be done in 3D too. I don't know. I don't want to confuse you guys too much. We've already done a lot of work there. So let's complete it. Let's take that one. And we will need some lines, right? Essentially, we need the rest of the piece of cardboard. As you guys know, we kind of have this bottom one already. But we need the other pieces. And we want it to follow the box, so I'm going to line up with each piece in the intersection. Good thing I drew outside of the box. We're going to essentially keep the alignment there, right? So enter. And I need my next piece. There, 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 and there. This can get pretty confusing, and to be fair, I'm drawing it all kinds of directions. You guys see that I'm kind of going back and forth. That is not the way to draw, right? Because all my lines are going to be all crazy flipped. But not the end of the world, right? Just make sure you get to the same piece. Take that line, click, basically using my edge and referring back to the original line, right? So, pop, sweet. And we got that piece. This piece should be actually fairly easy. There's my intersection, intersection, and intersection. And last but not least was one that we drew previously, that piece, and that intersection. So do make sure that you have the intersections enabled. So we'll take all those pieces and we'll trim them. So we don't need all the extra bits now. Already got some of that, of course. Now in my case, I probably got lines going everywhere, right? And as you can see, they are nuts, right? So what would I do? You know, Ellis? Make 2D, right? When I need something flat and I accidentally went through too much there, I'm gonna go ahead and make 2D. And I can of course separate those lines. Oh. Where'd my make 2D go? There it is. Oh, try again. I don't want to copy it. Make 2D. There we go. Group output. Oh man, I got the wrong view, even though that's very cool. Make sure you select the view that you want Make 2D to happen. Sweet. And for the most part, we got all the flat pieces, but now we got all the actual flat lines. So you'll notice if I click on this piece and this piece, it should actually get a couple of pieces for us. In my case, it doesn't look like the Make 2D was able to get all the pieces, so scratch that, right? Not gonna work for us. But that's okay. We can fix this one too. It's just gonna take a little bit more effort. So we'll take that piece, that curve point, and we basically need to move it up 12 inches because, well, the first one's moving up 12 inches. So I'll type in move, click really anywhere, 12 inches, enter, and of course move that up. So now that our first line is close, right, I kind of want to save that, so I'm going to join it. And I'm going to go ahead and extrude it here. That way I can kind of build as I go. So let's take that piece. Yeah, it looks pretty flat. And I think it is. We do have a lot of lines in there. As you can see, we definitely locked into that point over and over again. And it looks like this one's a little off too. So let's take that point. And again, kind of building it in a wireframe mode first. We'll take it, extrude, and go down. I'll join it just in case. And extrude. It does not want me to extrude this line. What is going on? Close curve, just in case maybe it's open. Maybe that's it. Nope, it's not an open curve. Bless you. Extrude. Oh, make sure you're choosing the right extrude. My bad. In my case, let's go down 12 inches. Sweet. And as you can see, we have the next layer of our cardboard, right? So on and so forth, right? So let's take those pieces, M for move, and again, just kind of go one piece at a time, right? It's not a race. Sometimes it is, but not today it is. Take that piece, move, and move that up. Nice and delicately. Oh, there it is. Move. It's looking pretty sweet. Go ahead and join that. Oh, I kind of have a point still going down there. As you can see, it probably would have been a lot easier to draw all these flat first than lift them up 1 foot. So I do apologize, but just in case you run into the same process, at least you'll know what to do. I do have another video where I do it a little bit better too. So if you just type in exercise 5, you'll find 2 videos on this one. So, and I'll leave those to be available. But let's get it right, you know, just in case you're having to do it the hard way too. There's nothing wrong with the hard way. The hard way teaches us a lot, so nothing too bad about it. Yeah, people laugh and they're like, "Ah, you're taking too long." But that's all right. Accuracy and understanding will always be more important in architecture. People can cry about how much things cost. And nothing will ever stop them from doing that. So, extrude. Oh, make sure you have the right extrude. I don't know why it's defaulting on extrude surface. Okay. Let's go down 12 inches. Voila. And as you can see, we're starting to kind of just build up that topography, right? And to be fair, it is pretty usable as a render, right? I mean, it looks like cardboard, right? And we could even set it to look even more like cardboard, but not really the point of today. Really, it's just the modeling part. And to be fair, if you guys come up with a better way to do this, by all means, you know, use it, refine it, share with the class. But let's get that next curve. And it looks like it's kind of hidden in there. That's okay. We'll move it on up. It looks like it has a couple points to move. So we'll take it up to the one that we know. Sometimes you do have to click on the whole line so that you can see where it is, especially if you didn't change the layers like I did. But we'll get there. Curve point, move. Obviously I'm just typing in M for move. And of course we can take that point. To be fair, we could do multiple points at the same time. Curve point. Curve point. Double click. Move. And 12 inches. Enter. Sweet. A little bit better that time. Woo, crazy. Join it. Nice. Extrude. Maybe it'll go to curve. Nope. Straight to surface. 12 inches. Nice. And we're getting a little bit faster. You know, I wonder. Nah, I've already gone too far. There it is. I'll take that piece. Slow and steady wins the race. Might as well move that one while we're at it. And there it is. Point, move, point, lock. Move, point, and lock. Yeah, as you can see, just draw these flat and rise them all up at once. Not a big deal. Yeah, it takes a little bit longer, but you know, sometimes it's not always about finishing first. Oh, that one's way off. Look at that. Way out there. Luckily, we already have these points to basically lock it onto. Makes it a little easier. Oh, I think I'm moving the entire piece instead of the point. Oops. It happens. Get that pretty close. I'm trying to do multiple layers at a time. It's not really working. But that's okay. Anyway, appreciate the patience, guys. And obviously in the recording, you could totally skip all of this, right? And just get to the part where it's finished. Nice. Join. Extrude. I don't know why it keeps going to surface. I don't use it that often. Couple layers to go, not too shabby. It's looking great. There's something about, you know, doing it by hand that's just kind of more rewarding. But oh my gosh, take that point. There we go. That one up. Maybe I didn't get any lines for those. Okay. Well, we can redraw them. And let's draw them actually where it'll be a little easier. So we can draw it. And we want it to go straight that way, but we want it to lock onto this piece. Right? And we can totally do that using smart grids. So technically, I guess this could be technically drawn in 3 dimensions. Not exactly easy though, as you can see. It doesn't really know how to lock onto an intersection point. So be careful. When in doubt, just choose that point that you know. That way you can lift it up 12 inches. See what it did there? Anyway, we're learning all kinds of stuff today, or at least how we would actually fix some of our errors, which to be fair is probably more important than just getting it right every time. But 12 inches, enter, straight, sweet. Let's take that next layer. We'll draw the next ones as well. Join, extrude. Not extrude surface, son of a... I don't know what remade my default, but okay. And 2 layers to go. Almost there, almost there. Let's draw that one again. Polyline. Put it to a point we know, put it to a point we know. And... oh. Wrong point. There's my point. Not too shabby. Get that guy up there. $12 inches. Sweet. Join. Extrude. Curve. Oh my god. It's pissing me off. Every time I've ever typed extrude, I meant curve, not surface. So it's kind of ridiculous that it keeps picking surface. And last but not least, let's get rid of that. Or just move it. And move it again. 12 inches. Sweet. It's looking a little off there, so let's draw it correctly. Boop. Take that piece, join, and extrude. Literally used extrude curve 12 times and it still wants to go to extrude surface. Does anybody else ever have that problem? Like it chooses a weird default there. Anyway, we made it. Looking pretty good, right? Not too shabby. And if we go into a rendered view, of course it looks pretty good for even diagramming or modeling or anything like that. And we already have all the pieces ready to go essentially for the laser cutter. So last but not least, our next step, we in fact I might leave it here actually, just because, well, eventually we want to put our stuff in and we of course want to model it out. However, we do want our columns to fit in here perfectly, right? So eventually we'll put our columns, so just kind of like, I don't know, for the sake of kind of working. I didn't really want to make an ellipse. I want to make a circle. And we'll do 6 inches. Eventually we want holes in our topography that actually indicate where we are, and sort of that way we can put our dowels in and do all kinds of things. However, really for this exercise, it's kind of a two-part series, I guess. Let me maybe remind myself. We can also use the model selected observation towers Boolean difference. Yeah, I think this is actually the one where I go into 3 different parts, and we do start putting things together. However, I won't get too ahead of myself. After all, it is the week before spring break, and I've already gone over a lot of bit and pieces of this. So just to kind of recap, we scaled our drawings, right? We found topography that we wanted to use anywhere in San Antonio. Of course, we made it a 48 by 48 square, and of course we started tracing it. And as you can see, we ran into all kinds of issues trying to make it a surface versus, you know, one or the other. But another thing that we can do is actually project these things onto, say, another surface, or get a surface first and make contour lines. So for instance, I can also go to terrain to STL. It's a very weird site called literally terrain to STL. But when you do that, you can essentially get a digital model from anywhere on Earth, even Nova Scotia. I guess it's stationed in Maine because it always goes to Maine first. But I'm going to find my location, in my case, San Pedro Park, and as you can see, I can only zoom in so much. So I'm basically going to center to view and get pretty close in there. I think I can actually make it a little bit smaller. Box width 2 by 2. And that's pretty good. I'm going to basically generate a model, download, and I'm just going to put on my desktop real quick and import that model. So I'm basically going to go the other way around. So if I had a surface, or I already made a surface, I can make topography lines to that surface as well. So not that this is necessarily a part of the project. You may need to use it, you may not. This is really kind of more for studio, and I like showing it just because you never know what you're going to get in studio. Very often, sometimes you'll get a project where they go, here's a topography surface already. Great. How do I make topography lines out of it? Right? So that answers this. So in my case, I just need to take that file. So desktop, terrain. I need to open it first and drag it right in. Of course, I'm going to import it. I don't want to open or insert the file. I do want to import it. I want to import it at the default settings. It's in millimeters, so I'm gonna switch it to. Actually, that's a really good question. Let's try feet. As you saw, it was really, really big. So yeah, it's probably millimeters that we should have stayed in, but not a big deal. Basically, it's gonna bring in a mesh. And as you can see, it doesn't like images too well. And let's take a look at that topography surface. As you can see, not a whole lot going on in rendered view. Let's take a look at it. And if we stretch it out quite a bit, we'll start to get kind of a topography surface from it. To be fair, we could use that for this project too, especially if you want to use a fictitious place that's maybe outside of the San Antonio, or maybe you don't have topography lines, right? How many of you guys have ever been in studio and you don't have topography lines of your location, right? You can find an STL, bring it into Rhino, and then of course contour it. So in our case, I'm going to chop off a significant portion of this just because that's kind of ridiculously huge. And I really just need that surface part. So in my case, let's trim it out. I could also, you'll notice that this is a mesh that we come in. If I type in what, it's going to go, it's a valid mesh, right? In fact, yep, geometry, valid mesh, which means it's essentially made up of a lot of triangles. As you can see, a lot of triangles involved. So I may need to go from mesh to NURB first. So mesh to NURB. This usually takes a lot of processing power. I'll hit enter. Actually went pretty darn quick, not gonna lie. Usually that does take a really long time. And if I type in what, there's the valid mesh. And you'll see that there's a slight difference between these. Right? If I type in what, it's a valid poly surface. Poly surfaces are things that we can wire cut. So let's get a easier portion to work with here. And in my case, let's delete the mesh and just work with the surface. I already have a 48 by 48. So I'm just gonna take that piece and kind of find a good spot. I'm gonna take my grid snap off. Not sure why it was kind of locking on there. But I can take that piece and wire cut it. So in my case, take that, wire cut, that one, all the way through. And that should be pretty good. Voila. Last but not least, let's wire cut the other side. So I wonder if I could use this for the same piece. Yeah, let's do it. Voila. We'll get a little piece in there. Wire cut. You gotta think in 3 dimensions, right? Oh, wrong side. Let's go with the Y direction. There we go. And voila, we chopped it. Essentially the exact same thing, but, well, a little bit different, right? It's more of a surface going on here. Now let's kind of put it with the other guys. And for the most part, really kind of the same thing, right? I mean, if we take a look at it in rendered view, it definitely has kind of a surface look to it. Definitely good for, you know, making perspective views or renders or things like that, where you don't necessarily want to see the steps of the topography. Maybe you kind of want to see it a little bit more realistically like a surface. So that's really nice, right? Especially for renders and things like that. However, I mentioned we want to get some topography lines out of it, and as you can see, it's pretty triangulated as well. We can shorten the divisions and things like that, but that's a little bit more advanced for today. What I want to show you is, of course, contours. So if we do contours, or contour, sorry, we can choose the base plane point, so in my case here, and you want to choose the direction that you want your layers. So in my case, I want my layers to go up, so I'm going to choose the Z direction. I'll just select another point. I want the contours to be each a foot or 12 inches. Enter. And voila. If I remove that piece a little quick, we have all of our layers ready for cutting. How easy was that? Now, as you can see, I have a lot of layers that are really the same. So all those rectangles, or squares in this case. But voila. I can have contours made just like that from a surface. So a little bit back and forth, but again, more of a tool rather than what we're trying to do is produce a product for this exercise. To be fair, it requires another tutorial. We're going to get a little bit into the laser cutting next time. However, it requires that the stairs are finished and the iterations are finished as well. So next time we're going to go over maybe putting those stairs together, and then of course putting all of that together into our topography to get it ready to laser cut. So we'll get into the minutia of it, but of course I would say for this exercise definitely pick the spot that you want to start contouring, and of course produce a model, whether it be the cardboard edition or a surface itself. Right? Could be pretty simple. You could make a surface knowing what you know now. You could still technically use loft, right? And of course cut these things. To be fair, I do it a whole nother way on my YouTube in the other episode as well. So if we take a look, view my channel, go to videos and go all the way down to exercise 5. Exercise 5 part 2. Yeah, I forgot. This one's got like 4 parts to it, so we're gonna get pretty into the minutia. Obviously, the first part we just went over today is this one right here, exercise 5 part 1, where it's specifically the topography. So just in case you have more questions, generally about the same video there, but yeah, as you can see, we're going to continue the conversation well into after spring break as we start to put these together. But any questions so far, guys, at least in terms of the instructions or what to do? So far, so good? Sweet. We'll leave it at that for today, being a pretty dense video. So just to recap, photos, contour lines, cardboard method, surface method, and vice versa. So if there's no questions, I'll leave it there for today. And I would say let's try and work to at least 10 o'clock today, guys. At least a good 35 minutes and getting some questions answered or finishing up assignment 3, 4, or starting number 5. So I'll leave it at that.